So following on from the previous video, when you're trying to determine whether an alternating series will converge or if it will diverge, you should perform the absolute convergence test first. So you should take the absolute version of this, and then the minute this converges, then you can immediately stop what you're doing and conclude that this thing will converge. But as it turns out, following on from the previous video, this thing here will diverge, so we have to do something else. But in general, try to perform this first, the absolute convergence test first. And if this fails, then do the following. So here we failed here. This thing here turns out to diverge. So now we have to revert back to the alternating series test. So when it fails, you've got to revert back to the alternating series test. So remember the alternating series test. We've done this before, so you've got to isolate the UN. So looking at this is what we're trying to determine. So you've got to isolate this. So ignore this. So ignore this, because looking at this, you ignore this. Just look at the UN. Just look at the UN. So just look at the UN here. First make sure that UN heads towards 0. So sine of 1 over n, does it head towards 0? Well, if you look at the sine graph looks like this. The sine graph looks like this. So 1 over n, well, as n heads towards infinity, this n here is going to get bigger and bigger and bigger, meaning the bubble itself here will head towards 0. It will never get to 0, because 1 over n, as n gets bigger and bigger, this thing here will just get smaller and smaller and smaller. It will never get to 0, meaning that what's happening is so when you look at this bubble here is heading towards 0. So you're actually heading towards 0, but you will never get to 0. So that means you're always hovering up. You are actually heading towards 0. You're hovering above the 0, but sine the bubble itself will head towards 0, because you can see. So sine looks like this. Sine looks like this, but this bubble here is heading towards 0, but it will never get to 0. So it's heading towards 0. So you can see that the whole thing itself here is heading towards 0. So this is true. UN is indeed heading towards 0. So number 3 is true. Now we need to check number 1. So make sure all the UNs are positive. So looking at this, make sure the UNs are positive. So sine looks like this. Well, in the realm from 1 to infinity. So this is from 1 to infinity. This is going to be positive, and sine, well, it's heading towards 0. It's going to be, the whole thing here is going to hover around here. It's going to be positive. This whole thing here will always be positive. So that's done. So now make sure that it's decreasing. Make sure that the whole thing here is going downhill. It could stay the same. It could stay the same, but make sure in general it goes downhill. So make sure this thing here is going downhill. Make sure the derivative is negative. So here we need to make sure that, hang on, we've done this before. So here make sure that the next term is smaller or bigger than this current term. So if you have a sequence like this, make sure the next one, this one is less than or equal to this one here. So meaning make sure it's going downhill. Make sure it's going downhill. Well, you making sure it's going downhill, it's really you mapping a function on top of this thing here. Mapping a function on top of this thing, and then differentiate the function. If the function is always, if the derivative is always negative, then you know the function itself is going downhill. So to determine number 2 here, we need to determine if this thing is going downhill. So map a function on top of this. Map a function on top of this, and then differentiate the function. So differentiating the function will then give you this. Well, remember, x is from 1 to all the way to infinity. So if you look at the course graph looks like this. As x moves from 1 to infinity, it's always going to be positive and it's heading towards 0. So this thing here is heading towards 0. So you can see that it's getting closer and closer and closer to 0, meaning that it's always positive. This thing is always positive. it's never going to be negative. So this thing here will be positive. But then here x here is heading from 1 to infinity. So now looking at this, remember this thing here is always positive. Looking at this, well, x is moving from 1 all the way to infinity. So this thing here will always be positive. Well, if this thing is positive and this is negative, then this thing here will always be negative. The whole block here itself will be negative, meaning that from 1 to infinity, this whole thing here will be negative, meaning that the gradient is negative, meaning that the function itself must be going downhill all the time. So going back to here, so that means un plus 1 will always, well, it's going downhill all the time. So this has been satisfied. Earlier this was satisfied. This was satisfied. Because all three have been satisfied, we can conclude that that this alternating series will converge. Okay. So in the previous video, we overall this thing here will converge. Okay.